Now there are a couple more things that we need to know about loops now that we know about for loops and while loops, and we've generally seen that there are some times when a for loop is more appropriate than a while loop and vice versa. It really ought to be noted that a lot of times what mechanism you use for looping is a matter of preference. Either one of these loops can be used in exchange for the other. So what I've got right down here is an example of a for loop over on the left that accomplishes that task we discussed previously of drawing an octagon. Because this was an instance where we knew very precisely how many times we would have to iterate a task, we chose to do that with a for loop. And as you can see from the code we have written, it's a little bit more concise. However, over here on the right is code that accomplishes the same purpose. It draws an octagon, and it's done with a while loop. Notice that what we've really done is just separated some of the tasks that are accomplished in line 3 into separate places. The way we've done that is we've created our own variable, this time a descriptive variable called numSides, and we've initialized that variable with a value of 0. The check we've then put on our loop is if the number of sides is less than 8. Because that's true initially, as in line 2 we've initiated numSides to be 0, we enter the body of the loop where we perform the same two tasks that are done over here in the body of the loop in the for loop, but our very last line is to increment numSides by 1. So numSides here is counting the number of sides that have been drawn after we've drawn them. And so numSides will hit 1, the flow of control will return to line 3 where we check this condition one more time. When numSides is 1, that truly is less than 8, and we'll execute this body again. And we will continue in that way until the 8th side has been drawn, and then numSides will hold the value of 8. When the flow of control returns to line 3, this condition will fail, and that's what will break us out of the loop and return the flow of control to the rest of the program. So we can accomplish the same thing with a while loop that we could accomplish with a for loop. And if we're willing to make some concessions, there are numerous times where we could do what a while loop ought to accomplish with a for loop. We'll see an example of that in a moment. One last thing that I absolutely must say about while loops in particular is because we allow them to execute for an unknown number of iterations, it is truly possible that you could get stuck in what's called an infinite loop, where the condition that we're checking for will never be false, and so the flow of control will never leave the body of that loop. For loops don't really have this issue as we're forcing the loop to iterate only a certain known number of times. But with while loops, you have to think about the possibility that you may never exit the loop. And such a loop where you get stuck inside of it and can never get out of the loop is called an infinite loop. So I'd like to show you an example of an infinite loop. Let's use our octagon example here, where I have the code that we just studied previously written right here. Because I was in charge of the counting, our very last line in the body of the loop was to increment numSides. So let's just see an example of how this code works properly currently. So when the code works properly, you can see that our octagon is drawn, our little turtle goes around 8 times, returns to its original starting location, and stops. Let's see what happens now when we comment out line 7, therefore creating an infinite loop. Because we never reassign a value to numSides, numSides starts with a value of 0, and that never changes. Therefore, this condition is always satisfied, and our program will just keep executing lines 4, 5, and 6 over and over and over again, and never get any further. And notice how that takes effect over here. Our little turtle doesn't trace the octagon one time and stop, but instead runs around in circles forever and ever as long as we keep this running. Last but not least, I'd like to show you an example where we can use a for loop instead of a while loop. Now it should be known that this for loop does not have exactly the same effect as a while loop, but it can hopefully mimic our while loop when it would naturally occur, and it has the benefit of distinctly not allowing for infinite loops within your program. So this time I'm going to return to the parking example where we were asking the user to input the number of hours that they would be visiting the parking facility, and we don't want to allow that user to proceed with the program until they've entered in a non-negative number of hours for what they will be parking. Now what we had done previously was created a while loop, and the condition that we had on our while loop was while the number of hours that the user had input was less than 0. What we could do that will have a similar effect is to create a for loop instead of a while loop that's going to execute some huge number of times. I chose 100 here just to be plenty big enough. We're assuming our user is just making a little typo. They don't need 100 tries to get that right. So some type of number that you believe is sufficiently large to encompass all types of forgiving situations. And so this loop is meant to execute 100 times to prompt the user for a number of hours. So we read in that number of hours from our user, cast it as a float, and assign that value to the variable num hours. So we do this one time. We are guaranteed to enter this for loop and gather this information at least one time. And after we gather that information from our user, we perform a check. What we're checking for in this particular situation is if the user entered good data. If the user entered proper data, something like they'll be parking for 3 hours, then we have the information that we want from our user. We don't want to be in the for loop anymore. And so we can use this special reserved word in Python called break. And what the break word does is it breaks us out of this loop that it's attributed to. So break will find the nearest loop and it will immediately exit you from the body of that loop and return the flow of control to the first statement outside of that body. So when we encounter this break statement right here, we will immediately get sent to line 7 and skip line 5 altogether. Now this break is part of the if statement. So the first thing we do after getting the number of hours from the users is we check for good and valid data. Should we encounter good and valid data, we immediately leave the loop. However, if our flow of control ever makes it to line 5 and we have failed this condition, then we will know unequivocally that we have had bad data. Another thing we could do is put this print statement inside of an else statement to make that more clear, and that would be just fine, but we don't even need the else if we don't want it. So should we make it to line 5 in the code, we will print to the user that they've entered an invalid number of hours, and at that point, we will start the loop again. So the benefit of doing this approach is that we know we will never get into an infinite loop. At worst, we will execute this 100 times. The instant that we get good data, we have a method for escaping the loop that's not built into this test criteria. So we have a way out. We aren't guaranteed to execute this many number of times. However, if we need to, we can keep reprompting the user until we get the data we're looking for, and then as soon as that happens, we can get out. So by using a for loop and a break statement, we can mimic a while loop and protect ourselves from infinite loops.